Now, before we move on, let's just discuss Java versus JavaScript. So right off the bat, just bear in mind JavaScript and Java are two separate languages. Java is to JavaScript as ham is to a hamster. People often confuse Java and JavaScript, and maybe the reason is that JavaScript has actually borrowed a lot of ideas from Java. Right? It's actually named after Java. And if we travel back in time about 5 years or so, this would be a simple comparison. It would have just been Java as a general purpose programming language, and JavaScript is used to make websites animated and fun. But now JavaScript's grown up. We know that. It's exploded. It's gone crazy. And the comparison between Java and JavaScript is more complicated. Perhaps the most fundamental difference between Java and JavaScript is that Java is considered a compiled programming language. JavaScript, on the other hand, is considered an interpreted scripting language. And the difference is in the implementation. We've been through this, remember? Java is compiled into bytecode and it runs on a virtual machine, whereas JavaScript can be interpreted directly by a browser. In the syntax it is written. Although, if you look at any JavaScript file sent over the web, you'll see that it's minified. It's condensed, so you can barely read it. But this is the main difference. Now, just before we end, let's just state a few more points between JavaScript and Java. One, they both run on the browser. JavaScript, we know this already, runs on every single browser out there. And Java applets can also be run on a browser, but they've been declining in popularity for various reasons, some including compatibility and security. Both can run on a server. Java has long been a major workhorse of the web, with application servers like WebSphere, JBoss, Apache Tomcat running on a large portion of the web application seen by users today. And although a while ago JavaScript wasn't that big in the server side of things, Node has come out, and this has enabled JavaScript-powered application servers to pop up all over the place. Both have libraries and frameworks. Libraries and frameworks help programmers by providing access to general and purpose-specific code that can be reused over and over again. And both Java and JavaScript are mature enough to have a wide range of libraries and framework options available. The next thing worth mentioning is two-stage versus runtime-only debugging. Java's compiled before it can be run, so if there are any structural problems with the code, they become apparent very quickly. And once it's running, IDEs often enable the developer to attach to the JVM to debug in real time. And remember, JavaScript is not compiled in the same way, so all bugs are found at runtime. The debugging capabilities of JavaScript are highly dependent on the execution environment, and this can vary quite a bit. Write once, run everywhere versus branching madness. What do I mean by this? Well, Java is specifically designed to enable developers to write code once and deploy it to any operating system without making changes. And in general, this does work as designed, although sometimes there are hiccups depending on the JVM and the code used. And let's turn to JavaScript. Although JavaScript has a standard through ECMAScript, it is much more susceptible to the differences in execution environments, normally in the form of different browsers. And while it's frustrating for developers to write JavaScript code for different environments, one silver lining is that the program itself can query the environment to decide what branch of code to run for that specific environment. Static versus dynamic type checking. Java uses static type checking, where the type of a variable is checked at compile time. So you as a programmer must specify the type, integer, double, string, etc. of any variable you create. JavaScript though uses dynamic typing. So what this means is that it's not required for you and I to specify the type of variable we're creating. There are many pros and cons for the two differences between how Java does it and how JavaScript does it. But the primary advantage of static type checking, right, this is Java, is that type errors are caught early in the development. And because the compiler knows exactly what data types are being used, code typically executes faster and uses less memory. But the quid pro quo is that the primary advantage of JavaScript, of dynamic type checking, is programmer productivity. You and I are free to design types at our leisure. We can work quickly and get the code out there.